What's good, code milkers? Today we're working on the problem construct binary search tree from Preorder Traversal. I haven't done this one yet. I saw the name of it and I figured I'd be able to do it because I've worked with binary search trees a lot. I've made my own NPM package for implementing like binary search trees and all those kind of data structures in JavaScript. So I feel like I'd be able to do this one in a reasonable amount of time. Return the root node of a binary search tree that matches the given preorder traversal. Recall that a BST is a binary tree where for every node, any descendant of node left has a value less than the current node's value. Any descendant of node right has a value greater than node value. Also recall that a preorder traversal displays the value of the node first, then traverses left, then right. Okay, so we have our example here. Preorder traversal would be, we go 8, 5, 1, 7, 10, 12. Because we go node first, then left, and then we go left, and we go right, and we go right, and then we go left and right. The only thing is that for each value we assign it to node val first instead of the left one. So we put 8 first, then we go to its left, and we take the next value, put it here, then we go left again, and put that next value here, then we go right, then we go right, and then we go left, that's null, then we go right, that's 12. Let's see. So an input 8, 5, 1, 7, 10, 12. Okay, oh nice. So the array is sorted in the way that we need to list the values. That's really nice for this. And then it ends up being 8, 5, 10, 1, 7, null, 12. Because if we're missing a node on one of the children of a node, it's just going to be null. Okay, so I'm going to make my preorder function, PO. It's going to take a node and a value. The node is the current node we're working with, so like could be node left or right or just the original node. And then value is going to be the current value we're taking from the input. And we're going to traverse that in order because it's already in the correct order for which we want to add to the binary search tree. Then we're going to make our binary search tree. We're going to start it off with null, just because we don't know if there's going to be anything in it. Then preorder for each function value. Okay, we'll give that a little space so it looks nicer. Okay, so if it starts off as null, we're going to need to reassign it to be a node. So this will have to return node. And since we have to reassign, we'll have BST is equal to PO BST and the current value. So this means from the root node, we're going to traverse in a preorder fashion down to the left or right or the current node and reassign the value based on where it should be starting from the root. So if it's like, say we start off with 8, that's going to be our first node because it's null. So we'll just reassign BST to be a tree node with empty children. So actually, let me put that in. So if node is equal to null, then we return new tree node with the current value. So now 8 is in. Then next we have 5, So since 5 is less than 8, we would go to the left and reassign that value. So if val is less than node.val, which would be 8 in our arbitrary iteration, we go to the left, and we have to reassign it because node left by default is null, so we have to reassign the property on the current node to make the change last more than, to make it mutable. So here we do node left is equal to po node.left, so we're recursing, and we take the current value down with it. So for node left, that means that we'll keep traversing until we find either a null, until we find a null root value, and then we'll reassign it there. This is going to be if val is greater than node val, in which case we go to the right. Okay, I'm gonna console log which value I'm at, because certain values should recurse more than other ones. Like 8 was only going to be logged once because it's the first, because the root is null and we just reassign it right there. 1 should recurse 1, 2, 3 times, as should 7 and 12. So I'm just going to console log it to make sure that the val is printing the right amount of times that we're recursing. Yeah, that did it right. Okay, let's try out an empty, and then a BST with only one node. Okay, that worked. Let's get rid of that, and we'll submit. Nice. Okay. 6%, not too bad. Thanks for watching. Have a great day.